The National Electrical Code, or NEC, does not permit the installation of a bare grounding conductor in a conduit with service entrance conductors. This requirement is based on several factors related to safety, electromagnetic interference, and proper system operation. Understanding the specific articles and sections of the NEC that govern grounding and service entrances is crucial for compliance and ensuring a safe electrical installation. Firstly, consider the function of service entrance conductors. These conductors carry the entire electrical load from the utility company's transformer to the main service disconnect of a building. They are the primary conductors that supply power to the entire electrical system. Because of the high current levels and potential for faults, service entrance conductors are subject to strict installation requirements. Secondly, understand the purpose of a grounding conductor. The grounding conductor, also referred to as the equipment grounding conductor or EGC, provides a low impedance path for fault current to return to the source, typically the transformer. This path facilitates the rapid operation of overcurrent protective devices such as circuit breakers or fuses, which disconnect the power and minimize the risk of electrical shock or fire during a fault condition. Grounding conductors are essential for safety, protecting both equipment and personnel. The NEC addresses the installation of service entrance conductors and grounding conductors in various articles. For service entrance conductors, Article 230 covers the requirements for service entrances, including conductor sizing, overcurrent protection, and methods of installation. Grounding and bonding requirements are detailed in Article 250. These articles work together to ensure a comprehensive approach to electrical safety. One key reason for not allowing a bare grounding conductor with service entrance conductors relates to induced currents and electromagnetic interference, or EMI. When alternating current flows through a conductor, it creates a magnetic field around the conductor. If a bare grounding conductor is installed in close proximity to service entrance conductors within a conduit, the alternating magnetic field from the energized conductors can induce a current in the grounding conductor. This induced current can cause several problems. Firstly, the induced current can lead to unwanted heating of the grounding conductor and the conduit itself. This heating effect, known as eddy current heating, can reduce the efficiency of the electrical system and potentially damage the insulation of the conductors. Secondly, the induced current can create electromagnetic interference, which can disrupt the operation of sensitive electronic equipment. EMI can cause communication errors, data loss, and other performance issues in devices such as computers, control systems, and medical equipment. Thirdly, the NEC specifies that grounding conductors must be insulated under certain conditions to prevent corrosion and ensure reliable performance. While bare copper conductors are permitted in some grounding applications, they are not generally allowed in direct contact with other conductors or metal surfaces within a conduit containing service entrance conductors. The presence of moisture or dissimilar metals can lead to galvanic corrosion, which can degrade the grounding conductor and reduce its effectiveness. Fourthly, consider the potential for increased impedance. When a grounding conductor is installed in a conduit with service entrance conductors, the magnetic field created by the energized conductors can increase the impedance of the grounding path. This effect, known as skin effect, causes the current to flow primarily on the surface of the conductor, effectively reducing the cross-sectional area available for conduction. Increased impedance reduces the effectiveness of the grounding system, making it less capable of quickly clearing fault currents. To comply with the NEC requirements, the grounding conductor must be installed separately from the service entrance conductors or, if installed in the same conduit, must be insulated. Insulating the grounding conductor minimizes the risk of induced currents, ME, and corrosion, and ensures that the grounding system operates effectively. There are several approved methods for installing grounding conductors in compliance with the NEC. One common method is to install the grounding conductor outside the conduit containing the service entrance conductors. This approach eliminates the risk of induced currents and simplifies the installation process. The grounding conductor can be run along the exterior of the conduit or buried directly in the earth, depending on the specific application and local requirements. Another acceptable method is to use an insulated grounding conductor within the same conduit as the service entrance conductors. The insulation provides a barrier that prevents direct contact between the grounding conductor and the energized conductors, minimizing the risk of induced currents and corrosion. The insulation must be rated for the voltage and temperature conditions of the installation and must be properly identified as a grounding conductor, typically with green insulation or green tape. When installing an insulated grounding conductor within a conduit, it is important to ensure that the conductor is properly sized according to the requirements of the NEC. The size of the grounding conductor must be based on the size of the service entrance conductors and the rating of the overcurrent protective devices. Table 250.122 in the NEC provides guidance on the appropriate size of grounding conductors for different circuit sizes. In addition to the grounding conductor, it is also important to properly bond all metal enclosures, raceways, and equipment to the grounding system. Bonding ensures that all conductive parts are at the same electrical potential, minimizing the risk of electrical shock. The NEC specifies detailed requirements for bonding in Article 250, including the use of bonding jumpers, bonding bushings, and other approved methods. For example, consider a service entrance installation using rigid metal conduit, or RMC. The RMC itself can serve as the equipment grounding conductor if it is properly installed and bonded. However, if the RMC is not properly bonded or if there are concerns about its ability to provide a reliable grounding path, a separate insulated grounding conductor should be installed within the conduit. Similarly, if the service entrance conductors are installed in electrical metallic tubing, or IM, the EMT can also serve as the equipment grounding conductor if it is properly installed and bonded. However, EMT is more susceptible to corrosion than RMC, so it is important to ensure that it is properly protected and maintained. When using flexible metal conduit, or FMC, or liquid-type flexible metal conduit, or LFMC, as a raceway for service entrance conductors, a separate equipment grounding conductor must always be installed. FMC and LFMC are not considered to be reliable grounding paths on their own, so a separate grounding conductor is required to provide a low impedance path for fault current. In summary, the NEC prohibits the installation of a bare grounding conductor in a conduit with service entrance conductors due to the risk of induced currents, ME, corrosion, and increased impedance. To comply with the NEC, the grounding conductor must be installed separately or, if installed in the same conduit, must be insulated. Proper grounding and bonding are essential for electrical safety, protecting both equipment and personnel from the hazards of electrical shock and fire. Always consult the NEC and local electrical codes for specific requirements and guidance on grounding and bonding. To further illustrate, let's consider a specific scenario. Suppose a building has a 200 amp service entrance. According to NEC Table 250.122, the minimum size of the equipment grounding conductor for a 200 amp service is number 6 American wire gauge copper. If the service entrance conductors are installed in a conduit, the grounding conductor must either be run separately from the conduit or, if installed in the same conduit, must be insulated. If the grounding conductor is run separately, it can be installed along the exterior of the conduit or buried directly in the earth. If the grounding conductor is installed in the same conduit, it must be insulated and must be properly identified as a grounding conductor, typically with green insulation or green tape. In addition to the grounding conductor, it is also important to properly bond all metal enclosures, raceways, and equipment to the grounding system. This includes bonding the service disconnect enclosure, the meter enclosure, and any other metal parts that could become energized during a fault condition. Bonding is typically accomplished using bonding jumpers, which are short lengths of copper wire that connect the metal parts together. The bonding jumpers must be sized according to the requirements of the NEC and must be securely connected to the metal parts using approved connectors. For example, the service disconnect enclosure must be bonded to the grounding electrode system, which typically consists of a ground rod, a ground plate, or a metal water pipe. The bonding conductor must be sized according to the requirements of the NEC and must be connected to the grounding electrode system using approved connectors. Similarly, the meter enclosure must be bonded to the service disconnect enclosure or to the grounding electrode system. This ensures that the meter enclosure is at the same electrical potential as the grounding system, minimizing the risk of electrical shock. Proper grounding and bonding are essential for electrical safety and are required by the NEC. Failure to comply with the NEC requirements can result in serious consequences, including electrical shock, fire, and equipment damage. Always consult a qualified electrician to ensure that your electrical system is properly grounded and bonded. In conclusion, understanding the NEC requirements for grounding and service entrances is critical for ensuring a safe and compliant electrical installation. The prohibition of bare grounding conductors and conduits with service entrance conductors is based on sound engineering principles and is designed to protect both equipment and personnel from the hazards of electricity. By following the NEC guidelines and working with qualified professionals, you can ensure that your electrical system is properly grounded and bonded, providing a safe and reliable source of power for your home or business. Remember to always refer to the latest edition of the NEC and local codes for the most up-to-date requirements and regulations.